Okay, hello. So, at the end of the previous video, I gave you this question. I asked you to think about a more general case with three reservations. There are three reservations for a restaurant or a flight, whatever you are comfortable with. So, A, B, C, three people, three passengers made a reservation for a flight, and each one has 10% cancellation probability. And the cancellation is independent across those passengers. Okay, in this situation, we are interested in the probability that only one of them is canceled, right? This is the binomial distribution. So let's think about how we handle this probability. So first thing here you need to think about is we have to, so actually like it is not that difficult to study this situation because there are only two possible outcomes for each reservation. And because there are three reservations, there are 2 times 2 times 2 number of outcomes, possible outcomes, right? Cancel, not, cancel, not, cancel, not. So you can imagine like three-dimensional table of all possible outcomes. So among them, among the 8 outcomes, we would like to calculate the probability that only one cancellation happened. Okay, so I listed all possible outcomes in this way, right? So like 0 means a reservation is not canceled. So not like the first outcome is that no reservation is canceled, and here only A is canceled, only B is canceled, only C is canceled, A, B canceled, A, C, B, C, and then all reservations canceled. So there are 8 possible combinations of the binary variables, and among these 8, we are looking for the probability of an event that includes these three outcomes, right? So these 3 outcomes satisfy the condition that the event that only one reservation is canceled. So we just need to count or calculate probabilities on these 3 outcomes. So again, the probability that the number of cancellation equals to 1 is sum of 3 possible outcomes. 3 possible outcomes, and we know how to calculate each probability. The probability of the first outcome, because A and B and C are independent, you can apply the special multiplication rule on each probability, and then basically what you do is you multiply the probability that A is canceled and to the probability that B is not canceled, and then C is not canceled. So probability of cancellation is 10% and non-cancellations are 90%. So 0.1 times 0.9 times 0.9. Similarly, the second one can be calculated by multiplication. 0.9, 0.1, 0.1. I like 0.9, excuse me. And 0.9, 0.9, 0.1, you multiply them. So then in the end, it is easy to see that these 3 different outcomes have the same probability, right? Basically, only 1 is canceled and 2 are not. So you are multiplying same probabilities. So at the end, we get 3 different scenarios, 3 different outcomes, and each of which has the same probability like this. This is the answer. Like, and if you calculate, so now we have learned 2 cases with 2 reservations and 3 reservations, and now let's find their commonalities. What's the common parts in their probabilities? So when you have 2 reservations, I asked you to calculate probability of 1 cancellation. It was calculated this way. And in 3 reservation case, we just calculated the probability this way. 3 times this. And then we can divide these probabilities into two parts conceptually. So the first part, we multiplied 2 because when there are only two reservations, there are only two possible combinations that satisfy this event, right? Either A cancels or B cancels. It is either A or B. But when there are three reservations, there are three different combinations that only one reservation is canceled. Like in three reservations case, it is either A or B or C. So that's why we have 3 here. So the first part is the number of different combinations or different outcomes in that event, in this event, right? So when you know the number of cancellations, you have to think about different outcomes, like different combinations. Where the cancellations are coming from, right? That is the first part. And then second part is the probability of a single outcome. As you just saw, because we are using the special multiplication rule, it doesn't matter who cancels. As long as only one cancellation happens, the probability of a single outcome does not depend on who cancels. Either A cancels or B cancels. Basically, their probabilities are the same, like this. Okay. So here, in these two simple cases, we learned the basic structures. This basic structure is a general rule, so we are going to keep them, but we need to study a little more about each part. First, we are going to start from the latter part. This part is actually easier, but the first part is much more complicated than you can expect right now. So let's talk about the second part first. So remember, we calculated the probability using the special multiplication rule using the independence assumption. Okay? So then pattern is clear. The pattern is simple. We are going to multiply 0.1, 10%, as many as cancellations. So we multiply 10% if canceled and multiply 90% if not canceled. Okay? So here, in the end, the probability of cancellations will be multiplied as many times as cancellations, and probability of non-cancellation will be multiplied as many times as non-cancellations happen. Okay? So, and as I said, it does not depend who cancels or who don't, right? So, like either A cancels or B cancels. Basically, multiplication is, what do we say? Like you can change the order of the multiplication, so it does not matter who cancels. So you can easily generalize this idea, right? So, like back to the general setup. Suppose that there are n reservations or n experiments. Random experiments is repeated n times, and we assume that P is the probability of success. In our example, success is cancellation and P is 10%. Okay? And if you are interested in the probability that the number of success equals to a lowercase y, right? Then the latter part of the probability can be calculated this way. P is the probability of success. That should be multiplied as many times as the number of success happened, right? So P should be multiplied lowercase y times, because we are interested in the case where success happens y number of times. So success happens y times with probability P. So P raised to the exponent of y. Also, you have to multiply failure probability too. Often this part is missing because we don't say that. We only say what is the probability of one cancellation. But when I say one cancellation, that also includes the information that the other reservations are not canceled. So you have to consider the other side of the event. So that means failure probability, failure happened this many times. So y is the number of success. So out of n, y are success, and of course n minus y must be the number of failures, right? So the failure probability is multiplied n minus y times, right? So again, imagine this way: there are n number of experiments, there are n different outcomes, and each of them has either success or failure. If it's success, then multiply p. If failure, multiply 1 minus p. So in total, you're going to multiply n number of probabilities using the special multiplication rule. But basically, there are two types, so you can classify them into multiplying p y times and 1 minus p and minus y times. So that is the second part of the probability is in a general setup, right? So then what remains is, so this is the success probability multiplied, and this is failure probability multiplied. So then what, let me go back here. We just formulated how this part is calculated. It was not that difficult at all. So pretty automatic. You multiply success as many as it happens and failure as many as it happens. But the remaining problem is this part, which requires a little more work. So I am going to generalize that idea to 4 reservations case. Now I generalize the example to one step further. Y is the number of cancellations as usual, but we consider 4 passengers or 4 tables, A, B, C, D, and everything else same. Probability of cancellation is 10% still, and cancellation is independent across reservations. In this case, I'm going to consider the probability that 2 of these 4 reservations are canceled. Exactly 2 are canceled, right? So then cancellation is success. So success happened twice and failure happened twice. Then what remains is the number of possible combinations under this event, right? So keep that in mind. If you understand that principle, now you can try to calculate this probability. Think about this probability. It is not easy yet, but just by trying yourself, I believe that helps to understand what we are going to study in the next video. Okay, so turn to the next video after you finish this work. Okay, see you later.